In one of my last videos, I showed you how you can use bigger nozzles on your Creality CR-10 and how you can adjust the print settings to create bigger prints faster. I had the problem that at higher print speeds, the Hotend was not able anymore to melt the plastic fast enough. So in this video, I'll show you how you can easily add an E3D Volcano Hotend to your CR-10. Guten Tag everybody, I'm Stefan and welcome to CNC Kitchen. So the CR-10 Hotend with its 0.4mm nozzle is not designed to print really fast. In the last video, when I installed an 0.6mm nozzle on my CR-10, the printer was not able to melt the plastic fast enough, so the extruder gear started skipping. The reason for all of this is still that I think that the nozzle and the Hotend setup for the CR-10 is not perfect if you want to use the whole print volume, because big prints would take too much time for someone who is as impatient as I am. The E3D Volcano Hotend is specially designed to handle a large flow of filament that you will have if you print fast with a big nozzle or both. It is basically just a long heater block with longer nozzles where the heater cartridge is mounted parallel to the extrusion path. The genuine Volcano Hotend can be purchased for around $30, including a set of 4 different nozzles from E3D and their resellers. There are China clones, but their quality is often questionable. When you compare the nozzle of a standard Hotend to the Volcano, you can already see the obvious difference. The Volcano nozzle is twice as long. The reason for this is that not the power of the heater block is the limiting factor for the material extrusion, but the thermal conductivity of the plastic itself. This means that in a normal nozzle you will have a big temperature gradient in the melt zone between the area where the material is touching the metal and the center of the filament. If you work with high flow rates, this can even be as worse as that the outer layer of the filament is molten, but the core is still solid, because the material was not long enough in the hot zone that you have a constant temperature in the melt. The Volcano Hotend is tackling this problem with doubling the length of the hot zone so that the material has twice the time to melt and to get to an even temperature distribution. This does not only allow you to print with bigger nozzles, but also, since the filament is properly and homogeneously molten, increase the layer adhesion. Since I only purchased the Volcano nozzle and not the E3D V6 heatsink, I was wondering if it was possible to replace only the heater block of the CR-10 without the need of replacing the heatsink as well. I didn't order the heatsink since I will be replacing the whole CR-10 Bowden system with the E3D Titan Aero direct extruder soon, because I just really don't like these compliant Bowden systems. There is one problem with only replacing the heater block. The CR-10 still uses one of these glass bead thermistors, whereas E3D switched to cartridge style thermistors quite a while ago. So the Volcano heat block that I ordered is also prepared for a cartridge style thermistor and not the one that the CR-10 has. Cutting the old thermistor and soldering in a cartridge style thermistor is not easily possible because they are a different type, and since Creality did not release their Marlin source code, you can't simply change that in firmware and re-upload it. Since I wanted to keep it simple in this video, I also found a way around that. I started by removing the fan shroud and peeled away the nasty insulation which is wrapped around the heater block. When that was done, I loosened the screw of the heater cartridge and the thermistor and pulled out both of them. Then I removed the heatsink and unscrewed the nozzle and the heat block. I thought I had the ingenious idea of also replacing the heat break with a genuine E3D one. After I finally forced out the glued CR-10 heat brake, I realized that the E3D heat brakes have a different thread on one side as they do have on the other, so I couldn't use it. I screwed it back in and thought about how I could reuse the glass bead thermistor. I finally decided to wrap it in Kapton tape once for electrical insulation and then wrap aluminum foil around it and compact it until it snugly fit into the designated hole. The thermistor is held by a small screw and you really have to be careful that you don't break the wires or crush the thermistor. I screwed the Volcano heat block back onto the heat brake and mounted it back on the X-axis carrier. The heat block is orientated in a way that the heater cartridge is in the front. You have to make sure that the hot end is perpendicular to the heat band, because otherwise you will get print problems. I did some minor cable management and put the fan shroud back into place. Since the heater cartridge of the CR-10 is kind of underpowered and the hot end fan always partly blows on the heater block, it's very important that you use the silicone sock that you can get for the Volcano. They insulate it and allow you to have more stable temperatures. You will need to cut a small edge away because this otherwise interferes with the X-carriage. Since the Volcano hot end is longer than the standard hot end, I still had to tackle two problems. First, the part cooling fan did not fit anymore and the C-axis end stop had to be changed. For the part cooling fan, I just adjusted my existing model from the last video and printed it out on my Prusa. For the Z end stop, I printed out a spacer which I fixed to the Z carriage with an existing bolt. Since the new nozzle distance was not perfect, I homed the printer and re-leveled the bed. When I turned on the printer with the new Volcano hot end for the first time, I got greeted with a min temp warning, which means that the thermistor has an infinite resistance, so I thought I destroyed it during the mounting process. After a short moment of frustration, I luckily noticed that I only had unplugged the whole hot end. After I fixed that, everything worked fine. Just for the fun of it, I taped the thermocouple to the Volcano nozzle to check if everything worked. The temperature was not spot on, but in the range you would imagine. Now you should actually run a PID tuning cycle for the hot end, but unfortunately it's kind of useless because the CR-10 does not save any set values to the EEPROM, so you will lose them as soon as you cut the power. Just another reason that I will exchange the whole extruder and reflash the firmware on the CR-10 with proper open Marlin in one of my next videos. Anyway, even though the PID settings in the stock firmware are not 100% perfect for the Volcano, it does print very well with the new hot end. After this modification, I did not have any issues anymore with the filament skipping and the prints looked very nice. Just for the fun of it, I tried out the 1.2mm nozzle, which was in the eruption pack. This means a 3 times bigger nozzle diameter, and if you print with a 3 times bigger layer height, 9 times more material flows as with a standard 0.4mm nozzle. That's crazy! This thing just chews through material like nothing I've ever seen. It is amazing to look at the stream of material which is coming out of the nozzle. The stock part cooling fan is also not strong enough anymore to cool all the material down, while my overhangs didn't look very good. Of course, with such a nozzle you cannot print small details, but you will be able to print big parts very fast and might even be able to use the look for artistic purposes. And since you are still able to use 0.4mm nozzles, you retain the possibility to print with the same amount of details as with the stock configuration. Since the melt zone is longer, you might have a little more drooping and probably need to slightly adjust some settings. By the way, if you look for a CR-10 and want to support the channel, then take a look at the link in the video's description. So this was a simple way how you can upgrade your Creality CR-10 with a Volcano hot end, which is reversible and does not require any soldering or fiddling around with the firmware. It's not perfect, but it should give you a considerable advantage over the stock hot end. I will be putting the E3D Titan Aero direct extruder on my CR-10 soon and reflash the firmware and hope that this will finally give me the perfect large volume printer that I need. In the meantime, consider supporting me on Patreon and subscribe if you haven't. Give the video a thumbs up and take a look at the other ones on my channel. Thanks for watching, auf Wiedersehen, and I will see you next time.